Swayam Prabha. Digital India. Educated India.
Welcome to the next session in the study of Organic Chemistry Paper 2. We will be studying the next module, which is related to some worked out problems basically from the alkyl halide reactions. In the lecture 1, I will be giving some general tips for problem solving. I am Dr. Balaji, Associate Professor, currently working as Associate Professor, currently working at School of Biotechnology, Jawaharlal Nehru University. This project is sponsored by DTH Swayam Prabha, MHRD, New Delhi. The topics that we will be covering in this particular session include some basic tips governing the general problem solving related to organic chemistry. The importance of what, why, how and when will be discussed to understand the holistic view of how to solve organic chemistry problems. I am sharing some tips for solving organic chemistry problems. Let us look at some of the tips how we can solve organic chemistry problems. I follow certain organic chemistry rules. The first and foremost thing is organic chemistry is sharing of electrons. So all the organic compounds are basically covalent compounds. So the bonds are formed by the sharing of electrons, and we generally deal with 4 elements in organic chemistry exclusively, or major cases revolve around the second row elements, that is carbon, nitrogen, oxygen, halogens and hydrogen also. So these are all the 4 or 5 elements which we will be dealing quite often, and the major difference between these compounds are electronegativity. So the halogens are highly electronegative, followed by oxygen, nitrogen, and carbon is less electronegative. Hydrogen is also another one which is also having certain electronegativity. So when a bond is formed, if it is a hydrocarbon bond or a carbon halogen bond or a carbon oxygen bond or carbon nitrogen bond, the electronegativity difference between the 2 elements is the one which is very crucial for organic chemical reactions. So basically, if you know what is the origin or the electron rich species and what is the electron deficient species, we can actually make an attempt to propose a reaction mechanism. Of course, there is one exceptional case, organometallic chemistry. When a metal comes into picture, the reactivity of the things keeps changing a lot. Say for example, if you take alkyl halides, the bond is polarized towards heteroatom, that is halogen. If it is a Grignard reagent, CMGX, that is RMGX. Now carbon, magnesium and halogen bond is formed. So the actual bond is between carbon and magnesium and not between carbon and halogen. So here there is a change in electronegativity, due to which the carbon now becomes electron rich or more electronegative compared to magnesium, the other part of the molecule. So by inserting metals, even the case with the silver also, so you have to remember all the time, in the absence of the metal, the electronegativity difference is between carbon and halogen. Halogen is more electronegative, but when we insert a metal, then carbon becomes more electronegative. So this is one of the things you have to remember, since organic chemistry deals with sharing of electrons. So which is more electronegative will try to pull the electron towards itself. So that is the one you have to always remember. This helps in deducing the reaction mechanisms or writing a plausible reaction mechanism, or we call that as a arrow pushing mechanism. So always remember, the electron rich species donates its electron to electron deficient species. That is how the organic chemistry reactions are occurring. In other words, we call them as a redox reactions or acid-base reactions. All basically revolve around electrons only. So you have to look at where is the electron rich part, where is the electron deficient part. If you can actually figure it out very quickly, then you can at least make 50% of the attempt to solve a problem. And it is also a better practice to write the lone pair of electrons, because often we ignore or we may forget to mention the lone pair on oxygen and nitrogen, due to which we may not see the electron rich species that is present there. So always remember to write the lone pair of electrons on oxygen and nitrogen. So this will exactly help you quickly identify what is the electron rich species in that particular molecule. And the second most important thing is, you cannot learn organic chemistry without understanding physical chemistry. That means thermodynamics and kinetics are most crucial for understanding organic chemistry. In other words, TD is here nothing but the thermodynamics or stability of the product. Kinetics is nothing but the rate of the reaction. So when a reaction occurs, you do need to know what substrate is getting converted into the product, which is more stable. If there are more than one product is possible, which is more stable is deciding factor under thermodynamic control. And what forms very quickly, that is energy of activation is lower, decides the rate of the reactions or the kinetics of the reaction. So it is better to know both the thermodynamic and kinetics of the reaction if we are going to solve a particular organic reaction. Then another important rule is, the product basically decides the course or the path of that reaction and not the reverse. Basically, a reaction mechanism is an imaginary path which is used to explain how the product is formed. Product is the reality, the reaction path is imaginary. Unless we can either isolate the intermediate or identify the intermediate, in most of the cases, we cannot predict how actually the reaction proceeds. There are various reactions for which we cannot even find out what is the intermediate involved. So, the path which the reaction takes is basically an imaginary path, but the products are real. So, the reaction mechanism is basically used to explain the product formation. So don't ever say if a mechanism doesn't apply, the product will not be formed. It is the other way around. If the products are not formed, then only we say this mechanism doesn't occur. Say for example, aromatic nucleophilic substitution happens, but it doesn't happen via SN1 or SN2 mechanism, which is the prevalent one which we follow in aliphatic systems. So nucleophilic substitution does happen in both aliphatic systems and aromatic systems, but they follow different path. That is the reason we say they can follow different mechanism, but aromatic nucleophilic substitution does exist. So SN1 or SN2 mechanism cannot be used to explain the product formation. So always remember, the mechanism is not the deciding factor. It is a product that is explained by the reaction mechanism. And in organic chemistry, we generally have various generalizations. Say, for example, we have Markovnikov rule or Zaitsev rule. So these are all some of the rules which we can generally use to predict the product. But the most important thing is, for every generalization, there are exceptions. In other words, anti-Markovnikov rule is also there. Hoffman rule is also there. Both are exactly opposite of Markovnikov rule and Zaitsev rule respectively. So every organic rule has an exception. So don't always say this is a generalized method. You have to look at individual substrate and the reaction conditions, the reagents, everything you have to take into consideration when you are trying to solve an organic chemistry problem. Now, here I put the most important one. So to solve an organic chemistry problems, you have to be like a Sherlock Holmes. So what is the main rule Sherlock Holmes follows in solving his problems is, he will rule out all the impossible ways or path. But improbable can happen. That is how he says. So in an organic chemistry reaction mechanism also, we have to make sure there is no impossible steps in the reaction mechanism. Improbable is possible. It can happen, but we are not so sure. But impossible cannot happen. So the same way we have to follow the same path how the Sherlock Holmes uses to solve his problems. We can also follow the same analogy or the same technique to solve organic chemistry problems. Now, the next question comes to our mind is, for the product formation, what is very important? Do we need to focus on how the product is formed? Or do we need to focus on why a product is formed? Or do we have to even think about when a product is formed? Or what product is formed? So these are all the different questions which we have to answer. So, which is very important? Do we have an answer? The answer is everything is very important. When we say how the reaction or how the product is formed, we are actually talking about reaction mechanism. So this is very important. And when we say why a product is formed, basically this is explained by the reactivity of the starting material, the reagents used, and the environmental parameters like temperature, solvent, concentration, etc. are involved in explaining why a particular product is formed. Then the next one to answer is when a product will be formed. This is basically explained by the rate of the reaction. That is, energy of activation of a particular reaction decides what product will be formed at what rate. So the rate of the reaction is basically explaining when the product will be formed. And what product will be formed is basically explained by the structure, size, shape, electronic nature of the starting material, reagents, and the reaction conditions used. So these are all the different and very crucial things for solving organic chemistry problems. Now I'm going to show an important thing for you to remember very easily. Remember all the time, electrophiles are eaten by hungry, powerful nucleophiles. So that means plus charges are neutralized by the negative charges. Remember, if you play video games, you may also have seen this particular game, Pac-Man, where this one eats up the dots. Let us assume, you can assume that these dots are nothing but your electrophiles, which are being eaten out by this particular Pac-Man. So this is arcade game people used to play long back. In summary, we have seen some of the basic tips that govern the general problem solving approaches related to organic chemistry. We also have studied about the importance of what, why, how and when. That is the importance of reaction mechanism and the stability, basically the thermodynamics of reactions, rate, the kinetics, and why we have to study what is activation energy and how it actually helps in understanding the rate of a particular reaction. And based on stability, how do we know whether which product will be formed or not can be studied. So all these basic fundamental things we have studied in this particular session. Thank you.